Hello everyone, welcome to Business Analytics Programming. This is week 11. Last week we introduced class. Now we're going to introduce more about the features of class such that it makes us life easier in programming. One of the very important feature in class is inheritance. Inheritance is one of the key functions in class that actually makes a lot of the programming work much easier. Here's the detail. One of the major advantages of using class is that we can create a new class called child class based on existing ones called parent class through inheritance. Basically, the child class gets all the attributes and methods from the parent class, and additional attributes and methods can be added to the new child class, which sounds very simple, but in reality, there are some steps to better illustrate that. For example, last week we created a class called car. And in this car class, we have four attributes. Basically, they are make, model, year, and odometer readings. Those are the four attributes. And four different kind of methods. Get a descriptive name, read odometer, update odometer, and increment odometer. Those are the four methods. And now suppose we want to create a new class which is called electric car. In addition to all the features of the car class, we want to add a few more attributes and methods. Okay, so we can create a electric car class from the scratch, but that is not the way we're going to do it. We actually will inherit from whatever we defined in the car class and add a few more. So this is basically we want to create a new class called electric car. It is a child class, and we're going to inherit all the good features including attributes and methods from the parent class, which is the car class. To define that the electric car class is a child class from the parents, we need to put the parent's name in the parentheses. So when we define a class based on the parent class name go into the parentheses. Remember, we will initially create the car class, we created it from scratch. It didn't inherit anything, so it is in the parentheses, the parameters are all 0. When we create a child class based on its parents, the parent's class name goes to the parentheses. Okay, by define the parents, we're actually explicitly tell Python that I'm going to create my electric car class based on the car class. And similarly, within the body, especially in the __init__ method function here, we have to put in the super parentheses dot __init__ and put all the parameters that is specified in the parent class except the self. So there are make, model, and year. So we have the make, model, and year here. And because we do not define the the odometer reading here, so we're not going to include the odometer reading here either. But by using this super function, the super method here, we specifically imported every attributes from the parent class as well as every method from the parent class. But we want to create something new to the electric car class. So we create another feature called battery size. The battery size is a new attribute, and we just use the self.battery size, and we define the default value to be 70 for the battery size in this particular case. In addition to all the four methods that are already defined in the car class, we actually define a new method called describe battery. method for the electric car class. So now for the electric car class, it has 5 attributes. That is make, model, year, odometer reading, as well as battery size. And it's going to have 5 methods. In addition to get a descriptive name, read odometer, update odometer, increment odometer, it now has a new method called describe battery. Okay, so because we're inheriting from the car class, so the electric car class definition is much easy to read. Once we define the electric car class, we can create an instance from this one. So for example, I'm using my underscore Tesla is equal to electric car with Tesla Model S 2016 as the input. That is the input to those 3 parameters. And then we can use the get descriptive name method from the new class here. Then we can use the new method describe battery to see what is the content. So very similarly as before, we create a new class called electric car by inheritance, and then we can create an instance of this particular class and use method to see what is within that class. Okay, this is a short summary of how we can use inheritance to create child class based on the parent class. So in summary, when a child class inherits from the parent class, the child class gets all the parent class attributes and methods. For instance of the child class, all the attributes and methods from the parent class are ready to use. New attributes and new methods can be added to the child class. There's no limit on how many new attributes or methods can be added in. We can override any methods inherent from the parent class that do not fit what we're trying to model with the new class. To do this, we define a method in the child class with the same name as the method we want to override in the parent class. When we use inheritance, we can make our child class retain what we need and override anything we do not need from the parent class. So it gives us a lot of advantage. So we can inherit from the parent class, we can keep whatever we want and override whatever we do not. So that's a very nice feature. It will save us a lot of time to create every class from scratch. Okay, so we can inherit class from the parent class, but when we model something real in real world, we may find we have to add more and more details to a class, which makes the class is not easy to understand. We can actually break large class into smaller classes and use smaller classes instance, that is the object, as the attributes for another class. That sounds very confusing, but through this example, we can make it clear. Okay, for example, for electric car, and everything related to electric car probably is related to the battery. That's the new feature. So let's aggregate all the features about battery and create a new class called battery. Okay, so we have our existing car class, which is the typical attributes and typical methods. But let's create a new class called battery, which contains all the information related to the battery that is used in an electric car. In this particular case, we create a class called battery, and from scratch we didn't inherit anything, and there's only one attribute, which is the battery size, and the default value, the parameter, actually the default value is 70, and we have the describe battery method associated with battery class. So we're trying to do exactly the same thing that we did just a moment ago. We create a new class called electric car, And in this electric car class is actually inherent from the car class. And the car class is still the parent. But in this particular case, we didn't actually define the details about battery within the electric car class definition. We actually use the battery class as the instance of the battery class as one of the attributes to the electric car class. So the electric car class inherits everything from the car class, but we create a new feature, a new attribute called battery. And this battery is not just one piece of information. It is actually an instance from the battery class. And the battery classes include the attribute battery size as well as method describe battery. And by using an instance of the battery class, we actually include all the parameter, the attributes, and the methods to be part of the electric car class. You may wonder, well, we can realize the same thing by just using inherent and define the battery size and define a new method in the electric class. Why we want to separate? The thing is, this is just only the simple features. In the battery, you may have 10 or 20 different features, and you may have 10 or 20 different kind of methods within your battery related functions. So instead of adding all the features and method into the electric car class, we can summarize the battery as a class with all the features and methods. Then we simply include an instance of the battery to the electric car class to make everything easy to understand and clear to track. So this is one of the advantage when we actually deal real world problem, and we usually modulize. We create a class called car, we create a class called battery, and then we can create a class called electric car based on inherent from the car class, and use an instance of the battery class as the battery attributes. So in this particular one, the attributes we see can be not only a single kind of variables, it can be a class in this particular one. Once we define the electric car class, we can actually define one instance. For example, my underscore Tesla is actually an instance from the electric car, and in this case, the electric car is defined as that. And we can print out, we can use the get descriptive name method. We can also find out what is the battery's property. So this is a little bit confusing here, but let's go into more detail. Okay, we can use my underscore Tesla, which is a class. We use a dot operator to access the battery. Battery basically is one of the attributes. So the my underscore Tesla dot battery is basically I want to access the battery attributes. But the battery is a class, it's an instance of the class. So we can use a method to describe that class. Then the method within the battery class is the describe battery. So it's the describe battery method to describe the battery feature in my underscore Tesla instance. So that's basically two steps to access the battery information. But at the end of the day, it just did what we want. It actually printed out what is the battery size. So in this example, we use a instance of class as a attributes, and it actually, by using that, we put anything related to battery into the battery class definition. Similar to have functions, to save functions into an external Python file, we can save classes into an external Python file as well, and it is called the module. And once classes are written to a Python file, we can import classes from the module. It is very similar to the functions that we mentioned a few weeks back. We can save functions into a Python file, and we can import functions later. So in this particular case, let's suppose we saved car, battery, and electric car classes into an external file called car.py. It is a text file. The name is car.py, and it is saved to the same directory of your Python notebook files. Once it is saved in the same folder, there are multiple ways you can actually import class. The first one is from car. The car is basically the file name for the .py file, but without the .py here. It is car, and from car import the class name. We specifically mentioned we're going to import car, battery, and electric car. All three classes we want to import. And because we define those three classes specifically, we can actually use the name specifically to create instance. For example, I can directly use electric car class to create an instance and then print out the detail. The second method is just import car, which is a file name for the .py file, but without the .py there. So because we didn't specifically specify which class we import, it is going to import every classes in that module. But because we didn't specify the names, so when we call the class definition, we have to use the file name dot the class name to basically define an instance of the class. In this particular example, we're using the car class, and we have to use car.car to actually create a instance of the car class. So that's two different kind of methods. In your textbook, you can find a couple more different ways you can import classes into your code. As we have already learned quite a lot about the classes and functions, how to import classes and functions, actually Python has a very rich collection of standard libraries that we can leverage. We use the import statement to import these classes that somebody already has been written for us. Python has already set the path, the file path, such that we do not need to have those modules in your .ipython notebook files location. So you can directly use the from collections import something to import the new classes. And there's actually is an example. When we first learned dictionary, we mentioned that there's no order for the key value pairs in a dictionary. But sometimes we'd like to keep the order of entries of dictionary. In standard Python library, there is a special class called ordered dict, which will keep the order of the key value pairs. Here's how we can actually use import to access the ordered dictionary class. First, we use the from collections import ordered dict. Basically, is imported this class, and then we create a dictionary, a particular dictionary called favorite language. We create an empty one, and then we add in the first key value pair. The key is Jean, value is Python. Then we'll add another one. The key is Sarah, the value is C, etc., etc. We add 4 key value pairs. And in the traditional dictionary, the order actually doesn't keep. The dictionary does not keep any order. But let's see for this new class. We're using a new class to create a dictionary. and you can see the order is actually preserved. So in the future, if you want a ordered key value pair for a dictionary, just do this. From collection, import ordered dic, and then you can actually create a empty dictionary, ordered dictionary by calling this, and then you can add the key value pair, and then the order will be preserved. So there are many more classes that you can use in the standard Python library. This is just one example. Okay, here's the homework. Read page 172 to 187 in chapter 9 of the textbook. Type and run all the Python codes between page 172 and 187 in chapter 9 of the textbook. And then for 523 student, there's an additional step. At page 178 of the textbook, try to yourself 9.6, finish 9.6, and upload to the college. Okay, that's it for this week. Bye.